Hi, in this video, I'm going to talk about goodness of fit test and contingency table. Okay. So, so in the last videos, I discussed about the chi-square distribution, right? Chi-square test was used to compare to test the hypothesis about the variance and the standard deviation, right? But it can also be used to test other things like independence of the two variables, whether two variables are dependent or independent, and homogeneity of proportion in the categorical data. Okay, so especially in the categorical data, if you want to test the homogeneity of the proportion, meaning that if two proportions are equal or not, or if three proportions are equal or not in the population. Okay, so if you want to test that, we can use the chi-square distribution. Okay, so the chi-square statistic can be used to see whether an observed sample fits a specific pattern. In other words, it can be used to test the claim that an observed frequency distribution fits some given expected frequency distribution. Okay, requires all expected frequencies greater than 5. So if it is less than 5, if some of the expected frequencies are less than 5, so we will do some other things, right? For example, you can combine with the another column, or you can use the Fisher exact test if some of the expected frequencies are less than 5. So we will see what is the observed and expected frequency next. The frequencies obtained from a sample are called observed, and the frequencies obtained from calculations based on preference are called expected frequencies. Expected frequencies are calculated by multiplying the total frequency with the probability of each category. So that is E equals to N times the P. That is N is the total frequency divided by the probability of each category. Okay, so let us do one example, then things will be clear for you. What it says is a medical researcher wishes to determine if the way people pay for their medical prescriptions is distributed as follows. Okay, 60% personal fund, 25% insurance, 15% Medicare. A random sample of 60 people found that this is the observed, right? Because that's what they observed. 60 people found that 38 paid with their own money, 16 paid using insurance, and 8 paid using Medicare. And at alpha equals 0.05, is the assumption correct? So what they want to test is if among all the medical bills, if the 60% were paid by personal fund, 25% were paid by insurance, and 15% are paid by Medicare or not. For that, they want to observe 60 people, and then they found that 38 use the personal fund, 16 use insurance, and 8 use Medicare. So you want to test that is this assumption is correct or not. So you are using both p-value method and R to test the hypothesis. Also, what would be an implication of this result? Okay, so let us find out. Let us list first what is the observed, and then we will find out what is the expected as well, right? There are three categories, right? One is personal fund. So let's say personal fund, right? And another is the insurance, another is the Medicare, right? So these are the three categories of the people that they want to test, right? If the 60% are paying from so they want to test if the 60% of the medical bills were paid by the personal fund, 25% by insurance, and 15% by Medicare. And they tested out of the total is 60, right? So let's write down total out of 60 people. Okay, so how many prescriptions were paid by personal fund is 38, right? Another is 16, right? And the another is 8. Now you want to find out the expected values. Okay, so the formula for the expected value we said was expected value is N times the P. N is the total number observed, N is the 60, times the P is the probability or the percentage, you can say. So what percentage of the people paid you want to check? So you want to test what percentage of the people paid by personal fund 60%, right? So what you want to do is you want to do 0.6, 0.6 for that, okay? So 60 times 0.6, so 60 times 0.6, okay? So how much is that? That will be the expected value for this will be 60 times 0.6 will be 36. That's what you get, right? Similarly, for the second one, that will be 60 times what is the percentage for the insurance is 25, right? So 60 times 0.25. If you do that, you will get how much you got here, 36. Here you will get 15. This will be 15. Similarly, you will get 9 here. So what is the total here? So 36 plus 15 is 51 plus 9 is 60, right? So you can round up if you get decimals, round up and down so that the total will be same as the total observed. Okay, so the total is almost equal. Okay, now to test the hypothesis, there are two methods. Okay, so the one method is do by hand and another method directly do using R. Okay, I will show you both methods, but you need to know both methods. But once you know, you can use R only because that is a lot easier and the faster. Okay, so what are the 4 steps for the hypothesis testing? Number 1 is write on H0 and H1, right? What is H0? H0 is the method of payment follows the assumption. What is the assumption? Is 60%, 25% and 15%. So the method of payment follow the assumption versus method of payments do not follow the assumption, right? So follow the assumption, follow the 60%, 0.6 is to 0.25 ratio is to 0.15, right? That is the assumption, right? 60%, 25% and 15% is the assumption there, right? And what is the follow the assumption, right? Assumptions. And it is do not follow the assumptions, right? Do not follow, because the observed follow the assumption versus observed do not follow the assumption. Follow the assumption, right? Assumptions. Okay. So number 2, you need to find the test value. So the test value is, since this is we are using chi-square test, we denote, let's denote by chi-square is equals to summation of OI minus EI square divided by this summation divide by EI, and then the square is only for the numerator, okay, and there is divide by EI. So what does that mean? That means this is O1, this is E1, O2, E2, O3, E3 and so on, but you don't need the total one, right? I just found a total one there. So what would that be? It will be 38 minus 36 square over 36, right? That is E1 plus, because this summation means add the difference, square of the difference divided by E, right? So that will be 16 minus 15 square over 15 plus 8 minus 9 square over 9. That's what you get, right? So what do you do next is you will find out the p-value, right? Number 3, you always use right tail test. That is important thing, okay? You always use right tail test. Where is that? So see, area on the right to the test statistics. So under this method, you need to use the right tail test, okay? Although it looks like a two tail, but when you use the p-value, you find out the area right of the test value. So if you do that, you will get basically the value you got is 0.2889, 0.2889 if you use calculator or R, okay? I'll show you how to do these steps by R directly, okay guys? So what is the p-value? So look at this node. This is the bigger chi-square means either the observed and expected frequencies have large difference, right? This difference is large, or they have many categories. If they have many categories, you will get bigger chi-square values, because see, you will have like so many terms in the summation. First term, there are just 3 categories. But if there are like many categories, like 20-30 categories, in that case your sum will be bigger as well. Or if that difference is bigger, then the sum will be bigger. Okay. And to find out the p-value is the area right of 0.2889. But what is the degrees of freedom here? Degrees of freedom is number of categories minus 1. There are 3 categories, right? This is the total I calculator. You don't need to worry about that. Okay, so 3 minus 1 is 2. That is the p-value. That is, how do I find out the area right? You should do 1 minus, right? Because the p chi-square, find the area left of that, but if you do 1 minus, then you will find out the area right of that, 0.2889, and then 2 degrees of freedom. You see that? 1 minus p chi-square, that. And what do you get? You got 0.86. 0.86. Is this p-value less than alpha or greater than alpha? What do we have the alpha values? Our alpha value is 0.05, right? 0.05, which is greater than. So you see that p is greater than alpha. So do not reject. Do not reject 80, right? Do not reject 80. What does that mean? That means you are saying that means of the method of the payments follow the assumption. Assumption is 60, 25, and 15% assumption for the personal phone insurance and the Medicare. Let me do all these steps by R, and then I will show you how to do by R directly without doing these steps. Okay, let us look at that. This is on lab 6. So what is the observed? Observed, I wrote C and then 38, 14, 8. You see that? Oh, 38, 16, 8, right? You should do 38, 16. Was that 16 or 14? 14, not 16. So 14. Yeah, it is 14. 38, 14, and then 8. And did I write 16? That should be 14. That is wrong, okay? 38, 14, 8. And then what is the probability? Probability is 60%, 25%, and 50%. Since there are more than one category, I am just writing C and then parenthesis. Similarly, the observed data. And what is the expected? Expected is probability times, it is like n times p, right? N times the p. N times the p is the expected one. That's what we got for the expected here. N times p. So n times p. That's what I did here. Okay. Now, what is the chi-squared? This is the test value, right? Chi-squared is sum of observed minus expected square divided by expected. That's what I wrote the formula. This is observed, this is expected, and divided by the expected. But there is sum of everything. Sum of that everything here. Okay. And then if you do that, let me run this code. Okay. Let me make it a little bigger. View and then go to zoom in. Let me do one more time. Okay. So see, observed is those numbers. Run that. P is the probability of each category or the assumption of each category, and expected is n times the p. So if you want to know what are the expected value, then I can run that and then see 36, 15, and 9. You see that? 36, 15, and 9. Now, I want to find out the chi-square is sum of observed minus expected square divided by expected. If you do that, you got chi-square is 0.288888 and 9. See that? We wrote that. 0.2889. Next, what? P-value is 1 minus P chi-square, that value. And then 2 degrees of freedom. Always use right tail test. Did you see that? You always use right tail test. And the degrees of freedom you take is number of category minus 1. That is 2. Okay. Let me run that. And you got p-value is 0.865. Actually, 0.87, right? P-value is 0.87 actually. Okay, 0.87, which is close. So, what do you get then? So the p-value is greater than alpha. So we do not reject 80, right? We do not reject 80. What does that mean? That means the observed frequencies or observed data follow the expectation. So they are very close. Okay, that's what you do. Now, how do I do that? Directly use chi-square test. Instead of doing all these, you can do that thing directly. Observed equals to that, expected, sorry, P equals to that, the probability equals to that. what you do is you do chi-square.test. Let me run that. Chi-square.test, you need observed, and P is equals to just P, that probability. So you need the probability for the expected and then observed data. Okay. If you do that, you get, did you see that? That the P value, the chi-squared value, the test value is 0.2889, and then degrees of freedom is 2. Okay. And then the probability, the P value is 0.8655. So the P value is greater than alpha. So we do not reject the null hypothesis. Okay, guys. So this is how you use R directly. Okay, you use R directly to test the hypothesis of whether observed data in a categorical distribution, in categorical data, whether the observed values or observed frequency follows the expected probability or expected percentage or expected values, okay, expected data or not. All right, so let us do another example here. Okay, let us look at this example. Hypothesis testing for goodness of fit test here is, does fire affect the deer preference on habitat selection? 6 months after fire burned the 730 acres of homogeneous deer habitat, researchers surveyed a 3,000 acre of land and surrounding the area, which they divided into 4 regions. That means there are 4 categories. The region near the heat of the burn, 520 acres. The inside edge of the burn, 210 acres. The outside edge of the burn, 240 acres, and the area outside the burn, 30 acres. Okay. They observed 75 deer in the whole region. See, this is the observed one. So that will be the expected one, right? This will be the observed one. So here in the expected, the percentage is not given. The probability is not given. So we'll have to find out. They observed 75 deer in the whole region, where 2 were in the region near the heat of the burn, in the very center, right? 12 were on the inside edge burn. 18 were on the inside edge of the burn. Outside edge of the burn. And 43 were outside the burn area. With alpha equals 0.05, test the claim that deer show no preference to any particular type of burned or unburned habitat. Use p-value method. So our hypothesis will be, null hypothesis will be deer show no preference, and alternative will be deer show some preference. So what we want to know is, depending on the size of these 4 categories, are those deer population are like concentrating in a certain region, certain type of region, or they are like equally distributed in all those regions depending on their sizes. Okay, that's what you want to check. So what I'm going to do here is, I want to find out, because the total number of deer observed were 75, right? So what I want to do is, I want to know the percentage of each category, and I will find out the expected value by multiplying the 75 with that percentage. Okay, look at that. H0 and H1 already discussed. So the chi-squared value is, chi-square equals to the test value is observed minus expected square over expected. So since the total land is 3,000 acres, I want to find out the percentage of each type. So near the heat of the burn, 520 acres. So 520 divided by 3,000 times 100%. That is 17.3%. Another is 7%, 8%, 67.7%, and so on. Now, so what is given is the number of deers in each of those categories are given there. So that is the observed one, right? 2, 12, 18, and 43. Now to find out the expected, what you need to do is, the total was 75, right? So I need to multiply 75 times 0.173, because what is the decimal of this? 0.173. Or you can say, what is the 17.3% of 75? 7% of 75, 8% of 75, 67.7% of 75. Find out these numbers here. Okay. So now you do exact same thing. Chi-square equals to OI minus EI square divided by EI. 2 minus 13 square divided by 13. 12 minus 5.25 square divided by that. this minus that square divided, and so on. So you will get chi-square equals to 43.2. That's the big value there, right? Now, here the number of category is k equals to 4. So the degrees of freedom is 3. Okay, you do exactly the same step I discussed here. Okay, guys. So what I'm going to do is I will show you this by using R. Okay, guys. So let us use R to do those calculations. Let us look at that. So observe is 2, 12. Let me show you that. 2, 12, 18, and 43. And what is the probability is you can write the percentage, or usually in here we use the probability or the percentage in terms of decimal. Okay, in the fraction or decimal you can write, so fraction or decimal you can write that way. Okay, so 520 over 3000. So this is 520 acre out of 3000, 210 acre out of 3000, and so on. So let me run this one and that one. And what is the expected is n times p, right? That is the expected. Now the chi-square is again sum of observed minus expected square divided by expected. You do that. And then the p-value is, again, you always use right tail test. So p-value is 1 minus p chi-square, and then 3 degrees of freedom. If you do that, this is what you get. The p-value is very, very small. 2.264995 times 10 to the negative 9. That is 0.000000 and then 2, right? So which is less than alpha. So we reject the null hypothesis, right? So you can do P is less than alpha. Okay, so if you want to do directly using R, what you do again is you put the fraction of the each land type or each region, okay, for the P, and then observed is observed. So you do chi-square dot test observed comma P equals to P. That is the probability or the fraction. Okay, so again p value is less than alpha. So one of the very important thing here is in all the hypothesis testing so far, we use significant level as 0.05 or confidence level as 0.95 or 0.90, 0.98, like that, right? So on those problems, on those testing the hypothesis, they were the quantitative, we had the quantitative data, right? We didn't have the categorical data there. We were testing the hypothesis for the quantitative data. But here we are using the categorical data. So we will not deal with the confidence interval. So on those cases, we used confidence interval also. We calculate the confidence interval together with the hypothesis testing. So here we are not using the confidence interval. So we don't have confidence interval. That is why what we are doing here is basically just finding the p-value. Okay, not the confidence interval. So for any alpha, it may be 0.05, 0.1, 0.01, 0.02, like that. For any alpha, what you are going to do here is you will compare with the p-value, right? For example, here what we got is, let me run that one. So this is what you got, right? So you got the p-value is 2.265 times 10 to the negative 9. So this p-value is very small. If your alpha value given by question, for example, here the alpha value is given as 0.05 here, right? So if your alpha value is bigger than the p-value, or if the p-value is less than the alpha, you always reject. It does not matter what value is alpha. If this p-value is less than whatever alpha is given there, then we reject all the time. So actually you don't need to enter that thing here, okay? Because you just need the p-value. You just calculate p-value without the significant level or significance level or confidence level there, okay? That's what the note is. Note that there is no significance level used on chi-test, as we will not calculate confidence interval. You do not need it just for hypothesis test, okay? You compare the p-value with given alpha in the question to make decision. That's what it is saying. Okay, guys. So that was the hypothesis test for this second example. On this slide, on slide number 9, okay, what is that? I think this is slide number 9 or slide number 8. I don't know. So on this slide, so I am doing directly, okay? What is it saying? Let us talk about this. So randomly selected occupational injuries and illness are categorized according to the day of the week they first occurred and the results are listed below. So these are the days of the week. Okay, these are categorical data again. So on the Sunday there are 24 injuries, Monday 23 injuries, Tuesday and so on. Okay, so it looks like you see that the total is 110. That is the N, right? In each category, these are the observed number of injuries. Do you think that Sunday and Monday are more likely to get injured than the other days, or they are the similar? That's what you want to test here, right? So you see that you want to test whether they are all similar, uniform, or they are not all similar. That's what you want to test here, right? So what you say is the H0, oops, sorry. So H0 is the number of injuries do not depend on days. And then H1 is depend on days. Depend on days means at different days they are different. Okay, now so if you want to say they do not depend on the days, then you are expecting, because your H0 is they do not depend on days, right? So you are expecting all the days have the equal number of injuries, right? See, so look at this. So 1, 2, 3, 4, 5 days. They are talking about the 5 days there, right? So Sunday, Monday, Tuesday, Wednesday, and Friday. There is no Thursdays here. This is the given data. So what you can see here is, or you can do Monday, Tuesday, Wednesday, Thursday, Friday. You can do that way. So it's just an example. So what you can do is, if they were all the same, then what do you expect is, so equal percentage, right? So there are 5 categories. All of the 5 categories must get the equal percentage there. Okay. So what does that mean? That means what the total is 110, right? And you divide by 5 will be 22. So all of them must get you are expecting the H0 is expecting all of them equal. So the observed is 24, 23, 22, 22, 19. This is the observed. The expected will be all 22. 22, 22, 22, 22. Because there are 5 days they are observing, right? And then if you want to have the equal, then it will be 1/5 of 1/5 of the total should be here, 1/5 here, 1/5 here, 1/5 here, 1/5 here, and so on. Okay. Again, alpha is given at 0.05. No worries about that. So what we are doing here then is, see, this is the observed one. The probability or the percentage, I said 1/5, because there are 5 days, and the null hypothesis saying that they are all equal. So 1/5 of the total of the observed, 1/5 of that, 1/5 of that, and so on. So what is the expected one then? The probability is that expected is 110 times the p, n times p, right? Do that. So what is the chi-square? Chi-square is the same formula, observed minus expected squared divided by expected. That is the chi-square. So the p-value is 1 minus chi-square again. The p-value you got is very big number. You see that? The p-value is very, very big number. That means we do not reject the null hypothesis, meaning that they are all equal. The injuries do not depend on those days listed there. Okay. So if you want to do directly by using R, this is what you get. You do, and then you do that 9589. That's what you got, right? 9589.9589, which is greater than alpha. Okay. So all right, that's what you got. So is that slide 8? I think that is a slide 9. Okay. The one that we just did was slide 8. The another must be slide 9. So what do you conclude from here? Since the p-value is greater than alpha, we do not reject the null hypothesis. Okay. So as p-value is greater than alpha, p is greater than alpha, we do not reject H0. Hence, the number of injuries are not different on those days listed. Okay, that's what you get there. All right. So so let us do example number 9. I think you have seen this type of example in your genetics class. All right. Let me read the example. So in a breeding experiment, white chickens with small combs were mated and produced 190. That's the total number of observed offsprings of the types shown in the accompanying table. White feather, small comb, 111. There are 4 categories and the frequencies of each category is given. The total is 190. Okay. There is 37 of them have white feather, large comb. 34 of them had white feather, small comb, and 8 of them had dark feather, large comb. So for alpha equals to 0.10, test whether the data consistent with the Mendelian expected ratio. So the Mendelian expected ratio is given like this. So the percentage is not given here, right? What is given? The Mendelian ratio is just given here. So how do I find out the percentage for that? See? It is like 9:3:3:1, right? So what is that? The total is 16 because 9 plus 6 is 15 plus 1 is 16. What you do is the P will be C 9 over 16, comma 3 over the total, comma 3 over the total, total, comma 1 over the total. This is the probability you will do there, okay? Because on that ratio, it is given in the ratio format, okay? Continuous ratio format. So to find out the percentage from that ratio, what you do is you add them and divide each of them by the total of that ratio. That will give you the probability. Okay, guys. So this is what I am doing here. You see that? The total observed is 111, 37, 34, and 8. And the P is that. Now expected is N times P again. Okay. And then you do it by hand. You got that. Let me run this. What do I get? Exactly the same steps. I got P is 0.67. Again, don't reject the null hypothesis, right? But if you want to do by hand, you need the probability and observed. Just do chi-square dot test. Okay. So if you do that, you got the same P value. So see, just 3 lines, right? So what do you get? The P value is greater than alpha. So do not reject, right? Do not reject. 80. Okay, so what was 80 in our problem on this problem is, so what is your null hypothesis here is the observed value follow the Mendelian ratio versus the alternative hypothesis will be observed value do not follow, okay? The observed value do not follow the Mendelian ratio. So since you did not reject the null hypothesis, so we say that these observed values are following the Mendelian ratio. Okay, guys, so this is how we perform a chi-square goodness of fit test to check whether an observed distribution or observed values of the categories, observed frequencies of the categories are following the expected frequencies of those categories or not.